looking at three types of permutations. So one we have already seen, the first one, which is if we have been given suppose if we have been given suppose 4 digits. So we have been given 4 digits 1, 2, 3 and 4, and we have to find the total number of 3-digit numbers which could be formed using these 4 digits without repetition. So we cannot repeat a digit more than once. Okay, so how we can do that? We have n equal to 4 here and r equal to 3. So we can simply find this using 4p3, which is 4 factorial upon 4 minus 3 factorial, which is 24. So in fact, we also saw another way to find this. If we have 3 blanks, the number of ways to fill this particular blank, the first one is 4 ways, because we have 4 digits to fill this first blank. Now we are left with 3 digits to fill the second blank. So the number of ways to do so is 3 and then 2. And if we use the fundamental law of permutation and combination and multiply this, we'll get 24, which is the required answer as we got from the formula of permutations. So this is 3. Now this was the first case which we looked at. Now suppose the second case. Now suppose we have again 4 digits and again we have to find the total number of 3-digit numbers that could be formed using these 4 digits, but in this case repetition is allowed. Okay, so in this case, if repetition is allowed, for if we have to form a 3-digit number, how many ways are there to fill the first blank? There are clearly 4 ways, because we can easily put 1, 2 or 3 or 4. How many ways are there to fill the second blank now? We still have 4 ways to fill the second blank. Why is that? Because even if we fill 1 here, then we can still fill 1 here, because the repetition is allowed here. So even we can fill 1 here. So there are 4 ways to even fill the last blank. So total number of ways to fill all these 3 blanks would be nothing but 4 into 4 into 4. We are again using the fundamental rule of permutations and combinations, which is nothing but 4 cube. Now if we generalize this, we will get n raised to power r. So therefore we get a permutation here. If we have been given n number of digits and we have to find the number of r digit numbers such that repetition is allowed, we can have n raised to power r such permutations. So this is the second type of permutation which we have studied here. Now we look at the final third type of permutation here. So suppose we have alphabets here. We have suppose A, B, C, D and D. So we have 2 A's and 1 B, 1 C and 2 D. Now what are the total number of ways to arrange these? We have 6 alphabets. So what are the total number of ways to arrange these 6 alphabets into 6 blanks? So we have to fill this 6 blanks with these 6 alphabets. Now we have to keep in mind here that if we are filling A, B, A, C, D, D, this is one permutation, and suppose we take this particular D here and this particular D here, so we will get D, D here, and we are keeping this same. Note that these two are same permutations. Why? Because this particular D and this particular D are no different. They are exactly the same. So we are getting alike characters here. We have alike characters here which will affect the number of permutation now which are possible given these particular alphabets. So here we have been given, we have 2 A's, 1 B, 1 C and 2 D. So the number of permutation in this case, and we can calculate n as 6, that is the total number of alphabets. So the number of permutation in this case would not be would not be 6p6, because we have r also as 6. So normally if we take all the d's and all the a's distinct from each other, then the number of permutation would be 6p6, which is 6 factorial. But this is not true in this case. In this case we have two a's and two d's which are exactly alike with each other. So a and a are alike and d and d are alike. So what are the total number of permutations in this case? In this case, the total number of permutations is not this, but 6 factorial upon the number of alike characters for A, that is 2 factorial. The number of alike characters for D, that is again 2 factorial. And that's it. We don't have to write 1 factorial because that will anyways be 1. So this is the required number of permutations, and this should be kept in mind because this is used in many cases. So you can just remember it that if we have n particular characters and r of them are alike to each other, another k of them are alike to each other, then we use this particular general formula. It could be any number of alike factorials in the denominator. So this is the third type of permutation which will be used in many cases.